Hello friends, welcome you all. In this video we will be discussing NFA with epsilon move. NFA with epsilon move. So what is this NFA with epsilon move? We have seen NFA without epsilon move earlier. Now we will see NFA with epsilon move. So in NFA, if we are without taking any input, if we are moving from one state to another, that means we are using epsilon transition there, epsilon transition without taking any input. If we can move to any other state, then it is called epsilon transition. And any NFA with that kind of transition is known as NFA with epsilon transition. So now we will discuss what is this, and first we will see the mathematical definition of this. And as you can see, it is again 5-tuple machine, and the meaning of all the tuples is same as DFA and NFA. Now only the difference is there, transition function. Only the difference is transition function. So I will discuss what is the transition function of NFA with the epsilon move. So here you can see, I can write it like this. So Q, we will see the present state of the machine, and then we will see the current symbol, input symbol that we are reading, and we can move to any subset of Q. We can move to any subset of Q. But here you can see, along with the input symbol, we are also using epsilon. So we can consider this epsilon union like this. So this is the transition function of uh, NFA with epsilon move. NFA with epsilon move. You can see here we are seeing the present state of the machine, and then we are seeing the current symbol, or we are having epsilon there, and with the help of this epsilon transition we are moving to any subset of Q. So that is the transition function of NFA with the epsilon move. Now, friends, we will see one example of NFA with epsilon move, and then you can understand it well. So now, friends, this is the example of NFA with epsilon move, and you can see here in this machine we have one epsilon transition there. We have one epsilon transition. So without using any input, we can move from Q0 to Q1. We can move from Q0 to Q1. So now, as Q0 is initial state, so when we are getting some input, so we have to stay on Q0 or we have to move to Q1. There is some uncertainty, and because of this uncertainty, we have this is NFA, and as we are having here one epsilon transition, so this is called NFA with epsilon move. Now, as we have seen already, like for every NFA, there exists equivalent DFA. So for every NFA with epsilon move, there exists equivalent NFA without epsilon move. That means again it can be converted into DFA. That can be ultimately converted into DFA. Or sometimes you can convert NFA with the epsilon move directly into DFA. So there are some processes that we will discuss definitely. So this is one example of NFA with epsilon move, and here you can see two states are there. Q0 is initial state, Q1 is final state, and from 0 on Q0 we have self loop of A, and we have on Q1 we have self loop of B, and there is one epsilon transition between A and the B. Now, dear friends, I will tell you what kind of language this particular NFA is representing. So you can see here, as on Q0, we have self loop of A. So here we can have any number of A, any number of A. So it can have any number of A followed by any number of B, followed by any number of B. But once we have moved to Q1, then we cannot go back to Q0, and then we cannot accept A. That means once we got QB, then we cannot have A. So any number of A's followed by any number of B's. So that would be the language of this machine. And if I represent this set as this language as set, so I can have epsilon because it can accept epsilon. See, this is final state, and without any taking any input with epsilon transition, it can move to from Q0 to Q1. So it can accept epsilon, and then it can accept A, it can accept B, it can accept AA, it can accept AB, it can accept BB, but you can not accept BA here. You cannot accept BA here. So that kind of string are there that can be generated, accepted by this machine. So this is the language of this particular NFA. And now this epsilon transition can be removed from this machine, and we can convert this into equivalent NFA without epsilon move. So now we will discuss the process of removing this epsilon transition, and then we can convert it to NFA without epsilon move. So friends, for converting this NFA with epsilon move to NFA without epsilon move, we need to use epsilon closure. Now, what is epsilon closure? So you can see here, epsilon closure of any state is the set of all states that we can reach with epsilon transition from this state. That means from Q0, how many states we can reach from Q0 with the help of epsilon transition. So that would be the epsilon closure of Q0. So I can take one example as this machine. So if we represent epsilon closure of Q0 as like this, so we can have, see, epsilon with epsilon transition, we can stay on Q0 itself. So this would contain Q0, as well as using this transition we can move to Q1 also. So Q1 will also be included in the epsilon closure of Q0. So you can see, for any state, epsilon closure of that state would always contain the state itself, because without taking any input, we can always stay on the current state. So that would always be included. Like for epsilon closure of Q0 will always contain Q0. Epsilon closure of Q1 will always contain Q1. That means epsilon closure of any state cannot be null set or cannot be phi nan. So that is epsilon closure of Q0. You can see we can stay on Q0 without taking any input, or with epsilon transition, or with this epsilon transition we can move to Q1. So I have included Q0 and Q1 both in the epsilon closure of Q0. Now if we find epsilon closure of Q1 in this particular machine, then you can see here, the direction of this transition is from Q0 to Q1. That means once we reach Q1, we cannot go back to Q0 using epsilon transition, or by any transition is not there in backward direction. So once we reach Q1, we cannot go back to Q0, or we need to stay on Q1 only. So epsilon transition without using any input, we can only stay on Q1 itself. So that would only be the state in epsilon closure of Q1. So these are the epsilon closure of both the states Q0 and Q1. So we will use these epsilon closure to remove this epsilon transition from this NFA, and then it will be converted into NFA without epsilon move. So now I will discuss the process of this. So I hope that epsilon closure would be very much clear to all of you. So we will make use of these epsilon closure for converting this to NFA without epsilon move. So now friends, we are going to convert this NFA with epsilon move to NFA without epsilon move. Now So now friends, we are going to convert this NFA with the epsilon move to NFA without epsilon move. So for this purpose, we are going to use this epsilon transition. And now I will consider one term here. I will suppose one term here, like delta. Suppose delta is the transition function of this NFA with epsilon move, and delta dash is the transition of NFA without epsilon move that we are going to convert into. So now you can see here, if we consider this, so on Q0, delta Q0 A, that means we are considering the transition of NFA with epsilon move. This belongs to NFA with epsilon move. And if we are considering Q0 comma A, that means it belongs, delta dash belongs to NFA without epsilon move. So now we need to find all transition for our combination. Like there are two states. So in the NFA with epsilon, without epsilon move also, their number of states would be same, and the number of input symbol would be same. So we need to take the transition. How many transition we need to find out? So delta dash Q0 on A, Q0 A, then delta dash Q0 comma B, the B transition on Q0, and then delta dash Q1 A and delta dash Q1 on B. So all these transitions belongs to NFA without epsilon move. Now, how we are going to find out these transitions? So you can see here, try to understand delta dash Q0A, delta dash Q0A. So in order to find out this transition, we will use epsilon closure of Q0. So as we are trying to find out the transition of Q0, so we will use the epsilon closure of Q0. So how many states are there in the epsilon closure of Q0? We will take all these states. So this would be equal to epsilon closure of Q0. This would be equal to epsilon closure of delta Q0 comma 0, Q0 comma 0 union epsilon closure of delta Q1, because Q0 and Q1 both are epsilon closure of Q0. So now you can calculate, now you can find out. So delta dash Q0, we will take, this will be equal to epsilon closure of delta Q0A union epsilon closure of delta Q1A, delta Q1A, and this is delta and this is delta dash. So this is transition of NFA with epsilon move. So now we will try to find out. So epsilon closure of delta Q0A. So what is delta Q0A? What is delta Q0A? Q0 on Q0, if we are getting A, so we are staying on Q0. So epsilon closure of Q0. Epsilon closure of Q0 union epsilon closure of delta Q1A. So on Q1 we do not have any transition of A. So that would be your phi. So epsilon transition of phi would be phi. Epsilon transition of union Q0 would be again Q0 Q1 union phi. So again this would be Q0 and Q1 itself. So in this way, in NFA without epsilon move, Q0 comma A transition would be Q0 Q1. The next state would be either Q0 or Q1. In the same way, friends, we can calculate Q0B, delta dash for Q0 comma B. So as we calculated Q0A, so for Q0B also we will consider both the states of epsilon closure of q0. So we will take epsilon closure of delta q0b union epsilon closure of delta q1b. So on now this delta we need to see here. So now you can see here on q0 we do not have any transition of b. So this would be epsilon. So if we calculate this, so delta dash q0 b would be epsilon closure of phi union epsilon closure of q1b. q1b q1 on q1 if we are getting b, so we are staying on q1. So epsilon closure of q1, and that would be phi union q1, because epsilon closure of q1 is q1 only. So that would be finally q1. So that means delta dash q0 b we have got q1. Now in the same way, friends, if we calculate delta dash q1a equal to q1a and delta dash q1b, then we will find in the same way we can calculate. So we will find as the epsilon closure of q1 is only having q1, so we will see the epsilon transition of a on q1. So that is there is no transition of a on q1, so that would be epsilon closure of q0, sorry, epsilon closure of delta q1a, and there is no transition for a on q1, so that would be epsilon and phi, that would be phi. And then here now we are finding this q1b, so that would be again epsilon closure of delta q1b, q1 comma b, and q1 comma b, if we are getting q1 b on q1, so we are staying on q1 also again. So that would be equal to epsilon closure of q1, epsilon closure of q1, which is q1 again. So that would be equal to q1. So now, friends, we have found all the transitions for NFA without epsilon move. NFA without epsilon move. So now we will make the transition diagram of this NFA now. Now you can see here we have two states. So again we will have q0 and q1. So now q0 is initial state, so we will remain it will be remain the initial state again. Now on q0 if we are getting a, so we are moving to we are staying on q0 or we are moving to q1. So we on a we can stay here or we can move to q1. On q0 if we are getting b, so we are moving to q1. On q1 if we are getting a, so we are getting phi, that means no transition of 1 on q1 or no transition of a on q1. Then on q1 if we are getting b, then we are moving to q1 itself. Now all these transition we have made. Now the question is what would be the final state. So now you can see my friend, in NFA with epsilon move, Q1 was the final state. In NFA with epsilon move, Q1 was the final state. So you check all the epsilon closure of all states, epsilon closure of all states, and wherever you are seeing Q1 as a member, make all these states as final state. So you can see, my friend, epsilon closure of Q0 is having Q1, and epsilon closure of q1 is having q1 itself. So both of these states would be the final state. And now, my friend, you can see there is no epsilon transition in this particular NFA. And then you can see the language of this NFA and this NFA is same. The language of this NFA and this NFA is same. So this is NFA without epsilon move, and this is NFA with epsilon move. I hope, friends, it would be very clear to all of you. And if you have still any doubt, you can write in comments. I will definitely reply your comments. Thank you so much.